Science at its best encourages us to consider every perspective, even those that are unpopular. But today, many of us are witnessing something different. Rigid adherence to consensus is being elevated above open inquiry. Scientists who question the prevailing view are often silenced rather than engaged with. This is a problem, one that matters more now than ever before. Real science is about asking questions, not providing easy answers. It's about the pursuit of understanding, not the comfort of consensus. True scientific progress comes from a continuous dialogue between proposed hypotheses, their challenge, and subsequent revisions. As Karl Popper famously stated, science is a never-ending dialogue with reality. Falsifiability, the ability to be proven wrong, is what keeps this dialogue honest and productive. Yet much of modern science has come to equate legitimate research with the maintenance of peer-reviewed consensus and credentials rather than the rigorous testing of ideas. The result is a system that often struggles to handle dissent, pushing it to the margins and sometimes stifling it altogether. This issue is so widespread and significant that it has been dubbed the replication crisis. A 2015 study published in Nature reported that more than 70% of scientists had failed to reproduce other scientists' results, and that more than half could not replicate their own. The Reproducibility Project, that was an effort to replicate 100 psychology studies, managed to replicate only about 36%, with significant results that were on average 85% smaller. Cancer biology fared similarly, with almost 50% of experiments failing replication and similar reductions in effect sizes. Why does this happen? Well, several factors contribute, but one major issue is incentives. Scientists are incentivized to find positive results, to make a name for themselves and secure funding. As a result, methods that consistently yield publishable results, regardless of their truth, have a natural selection advantage. This means that the loudest, most prevalent voices may not always reflect the most accurate or robust science. When dissenting findings emerge, journals often bury them in the proverbial file drawer, resulting in the file drawer effect, which skews consensus. Now you might be thinking, what's wrong with consensus? After all, it seems desirable to have a general agreement within the scientific community, right? Well, let's think. Thomas Gold, a Nobel Prize-winning scientist, once said, "The first principle is that you must not hypersensitive to, the disagreement. You must not feel that disagreement is an attack on you personally. The disagreement is what makes science grow. The idea that science marches forward through unchallenged consensus is a misconception. Healthy skepticism, not blind trust, is what drives scientific progress. In fact, the process by which consensus is reached is often more complex and nuanced than it appears. Paradigms shift as new evidence emerges, interpretations change, and debates rage. A striking example of this is the controversy surrounding climate skepticism. While it is claimed that most climate scientists agree that human activity is causing global warming, a seemingly small but vocal minority disagrees. Now, it is said that most of these dissenting views are not well-founded. But it is difficult to know for sure if the views are censored by the ruling political majority. However, they remain controversial, partly because the media often present every dissent as unimportant, if they mention it at all, giving a false impression of balance. This false balance problem can lead to confusion, because it's easy to claim overwhelming consensus if dissenters is silenced, giving people the false impression that all scientists agree and that the science is settled. But what is the reality? But here's the thing. True science thrives on dissent, not ideological echo chambers. It's not just systems that struggle with dissent. We humans do too. Our brains are wired to double down. When our understanding of the world is challenged, our amygdala, which is the part of the brain responsible for processing fear and threat, lights up. Studies have found that people with larger amygdalae are more resistant to changing their opinions, even in the face of clear evidence. One interesting study even found a correlation between amygdala volume and political conservatism, suggesting that a larger fear center might lead to a greater discomfort with uncertainty and complexity. When simple answers are more comfortable than uncomfortable truths, people turn to authorities to shield them from unsettling realities. But when those authorities engage in groupthink and shut down dissent, public trust erodes, leaving us without robust science to guide us through an increasingly complex world. The consequences are evident in everything from climate change criticism to anti-vaccine movements. What are some examples of this happening? Let's take cold fusion, the controversial 1989 claim that a team of scientists had achieved nuclear fusion at room temperature and low energy. Despite being ridiculed by a majority of scientists, including some of the most prominent names in the field, this claim wasn't completely unfounded. Follow-up experiments showed intriguing results and raised questions about the initial dismissal. Yet the consensus view prevailed, possibly stifling further investigation into a potentially groundbreaking phenomenon. More recently, the question of COVID-19 origins has been politicized, with early hypotheses of a lab leak being sidelined to suit political expedience. In nutrition science, guidelines have shifted dramatically over the years. Once demonized as artery-clogging villains, saturated fats and cholesterol have made a comeback as dietary essentials. Each shift reflects a nuanced understanding of the evidence and the importance of remaining open to new findings. So what can we do to move forward? How do we rediscover the lost art of listening in science? First, we need to promote open data and registered reports, where researchers publish their methods and data before knowing the outcomes, reducing incentives for cherry-picking results. Second, we need to fund and value replication studies, even if they don't overturn original findings. Third, we need to reward methodological rigor and transparency, not just novel and flashy results. Fourth, we need to encourage the publication of negative findings to counter the bias towards positive ones. Finally, we need to celebrate disagreement, responsibly and clearly distinguish between evidence-based and ideologically driven criticism. By doing so, we can restore the integrity of science and ensure that it remains a beacon of truth. It's untouched by political correctness. In an increasingly polarized world, science is not about silencing dissent or crushing opposing views. It's about embracing them, scrutinizing them, and ultimately, if they stand up to the test of evidence, integrating them. It's a dynamic equilibrium of questioning, testing, and revising. It's through this continuous process that science advances, not through the comfort of consensus, but through the courage of open inquiry.